Hi everyone. In this given problem statement of n queen 2, we are given an n queen puzzle is the problem of placing n queen in an array or a two-dimensional array of n cross n chessboard such that no two queens can attack each other. So this is a classical backtracking problem. So let me create a chessboard. Let me create a 4 cross 4 because if it's a 3 cross 3, right, there is no possible way of placing 3 queens in a 3 cross 3 board because it's not going to work. So if you know chess, right, so a queen can move to its left, can move to left, right, down, and on the it can go on the up. It can also move in this direction. In this direction, diagonally, it can move. So it can move in 8 direction. So the first thing we can do, right, we can place, this is the column wise and this would be the column. So 0 1 2 3, 0 1 2 3, and this would be the row wise structure. So I can place the queen in this index. Okay, the next queen, right, because I can create a set value which is called column, and I can say the first column is occupied or it's in this set. So I added, or let's say 0, not 1 but 0, and the first column is occupied. Now for the second one, right, I can't place a queen in this direction because it's already occupied, and if I place the queen here, then this queen is going to attack here. What is the alternative? So the alternative is adding the queen here, but if I add it here, then this queen is going to attack again. So I can place the queen at this position, and as of now I would be seeing that there is no attack that is possible because it cannot attack diagonally. The second one, right, can I place it here? If I place it here, right, this queen is going to attack. If I place it here, so this queen is going to attack. If I place it here, this queen is going to attack, and if I place it here, this is going to attack. So there is no possible way of doing it. So what I will do, right, I will backtrack to this queen and I will move it to this place for the time being, and I just remove it from here. Then I will again try. So at this position, right, I can place this queen out here, and I am able to see no one can attack here. Then I will go to 3. I can't place it here, can't place it here, can't place it here, can't place it here. All of the attacks will going to happen. So the alternative for me, right, I will again backtrack. Then I would be able to see, right, I can't place this queen out here. I can't place this queen out here. So none of the possibilities working. Then I will backtrack to this queen, and I can't move it here because it's going to out of bounds, so it's not going to work. So I'm again going to remove it and backtrack to this one. Here, from here, right, I can move this queen to this position, removing this one. Okay, so once I have done that, right, the second possibility, I will again start from the row 1. I can't place it here. All the 3s are not possible. I can place this queen out here. So this would be my new second queen. The third queen, right? Can I place the third queen out here? Yes, I can. And I will place it up here. Then the fourth queen, can I place the fourth queen out here? On this index, I can't. This one I can't, but here I can. So I can place the queen here. So right, so this would be the my final set, and if you look into it, right, in the first diagram, so this is one possibility. Similarly, right, I can keep on backtracking to find all the possibilities where I can place the queens or all the distinct solution. So I've shown you one. Now from here, right, we are able to understand, right, we have to keep track of few things. First is that which column is occupied by the current queen. So here, right, I'm creating a set, so I can say column, I can create a set, or let's say column equal to set. To keep a set, so let's say it's already occupied by one, right, I can't place it there. The second thing, right, and it's a very ingenious way that they have find out, right. So one way, right, how will I understand, right, it can go infinitely, so it's going to be very very difficult, right. So I can say column positive. So what is column positive? If I do this diagram, 0 1 2 3, 0 1 2 3. So if I look into it, right, column positive would be row plus columns, it would be 0 2 4 6, then it is 0 and 1 is 1, 0 and 1 is 1, 0 2 is 2, 2 3 3, 0 1 2 is 3, 2 1 is 3, 3 1 is 4, 3 1 4, 5 and 5. So here, right, am I getting some combination? So if I look into it, right, yes, I'm able to understand, right, there is some combination that is happening. So let's say if I place the queen at this position, right, let's say at q, right, so it can attack any row, let's say 1 it can attack, or let's say if I place the queen at this position, right, it can keep on attacking all the values are 2 2 2, then 3 3 3, then 4 4 4 5 5. So this is the one way of doing it. The other is, if I look into it, it's a pretty ingenious way of doing it. Otherwise you have to keep on the index, right. So it would be, let's say if I place the queen, right, so I it can attack 0 0 1 1, then 2 2, and in that way, right, I have to keep an index. It's better to keep it in this format, it would be easier. Now the second thing that we need to look into, which is, again it would be 0 1 2 3, 0 1 2 3, and this would be negative position. So negative position, the name suggests, right, so it would be 0 0 0 0. So row minus column, so minus 1, and so minus 2 minus 3 minus 1 minus 2 positive 1 positive 1 positive 1, and this is also going to be 3 minus 2 minus 3, right, is minus 1. So 2 1 and 3 is 2, and 0 3. So here, right, I hope that you're able to understand, right, if whenever we add it, right, we have to add two values, right, what column we are. So it would be column dot add the current column we are in, then it would be positive position dot add, it would be row plus column, and negative position dot add row minus column. And if we are going to check for the condition, right, if my current let's say we are going to iterate through C, right? So if C in column, or C plus R in positive position, or R minus C in negative position, then we can just return and stop the iteration. So this would be the basic idea of how to solve this backtracking. So there would be few things to remember, right? One is the backtracking. The second is that how we are managing the diagonal attack of our queens, right? That through that, to do that, right, we have to create this one. Other would be very, very complicated to match, because now it's like 4 cross 4, right? But there could be a situation of 40 cross 40 matrix if it is the solution thing, right? So you cannot keep on iterating. That would be a big number, so it's no longer going to be possible. So you need to know these tricks. And now let us quickly jump to the Python solution. The first thing that we're going to do, right, we are going to initialize our board. Initially, right, is going to be an empty value. So let me initialize with dot for I in range. It's an 4 cross 4. So for j in range n, and if I print it, right, if I run it, I'm going to get a 2D list. Initially, right, our board is empty, so we are going to get the values. Now what we need to do, right, we need to create our set to keep a track, right, in which column, right, we cannot add any more queens, so that the same queen cannot attack the other one. And also I need to create a positive diagonal, which is also going to get with set, and a negative diagonal, which is also going to be a set. I create a function called def backtracking, and here I'm going to pass in the current row. Let me check the spelling. Backtracking. And here, right, if my row is basically the same as the number of, basically, right, we have placed all the queens. In that case, also I forgot to add one more thing. I need a variable called result to store the result that we have created. So here, right, it would be result dot append, and whatever the current board value is, I can do a copy, because it's a recursion problem, right? And if I just add board, right, it would be a pass by reference, and the same value is going to keep on changing over time. So we need to create a copy. So, and I can return it up, return. In the other condition, right, I can say for C in range 0 to n, if the C is already in the column, or R plus C in positive diagonal, or R minus C in negative diagonal. That basically means that some of the queen that we placed earlier, right? It's already attacking the current queen. So I can say continue. And I will keep on iterating. In the other case, right, if it's not happening, then I can say column dot add the current value. So it would be C, positive diagonal. Also you have to add the R plus C. It would be dot add. And the negative diagonal dot add R minus C. And we're going to call the backtrack function. It would be R plus 1. In case, right, this does not work, right, then we have to backtrack. So in that case, what I can do, it would be column dot remove C, positive diagonal dot remove R plus C, and negative diagonal dot remove R minus C. So this is our entire function, and here I can call the backtracking, and I can initial value of row would be 0, and I can return the result. Let me run it up. I hope it works. Let's see. Yeah, I made one mistake, which is I didn't name the function properly. So back tracking, backtracking. Let me run it up now. Yeah, so here, right, okay, I did also one more mistake, right, which is I will have to place a queen, right? So board of R and C, I will be replacing it with the queen. And in case if I'm removing it, right, so I will be again changing it value to the dot. So that's the idea. Let me run it up. Yeah, I made one more error, right, which is it would be multiplied by n and not a loop. So it created a triple nested value. So I need to check that. So if I run it right, I think it should give me the proper result. Let's see. Still not. Yeah, I think I'm making one more error, right? So simply copying the value, right, won't work because it's not proper. So I can do one thing, which is dot join the current row for row in board, and instead of that I can just pass in the copy variable. So let me run it back again. Here, right, now if you look into it, right, it looks somewhat similar. So we are able to get two values, right? And if we quickly analyze it, right, so these two values, right, how we are placing our queens and at which position. But if we look into the result, right, it does not want the position of the queen. It just wants the number of distinct solution to the n queen puzzle. So distinct solution would be whatever the result we got, we just want to get the length. So length of the result. And if I run back again, it should give me the result, and let me submit it up. As you could see, it ran successfully. It is beating 64.89% of the solution. And if I look into the time complexity of it, right, so in the best case it would be factorial big O of n factorial. In the worst case it would be n square n, which is a huge number. So generally these backtracking problems have a very bad time complexity. So in many cases, right, these backtracking solutions are going to get used with dynamic programming. In this one, we just limit our scope to just backtracking. Hopefully in the dynamic programming section, when you're going to study it, right, we are going to solve more and more problems on those. That's all for this video. See you in the next one.